Hello everyone, welcome to experiment 7 of 247 courses laboratory. This experiment is generally about data transfer operations. Also, we will see some MATLAB functions to read or write Excel files or TXT files. Okay, let's begin with first part. It says, perform the following operations. In this question, we will first create an Excel file like this one, example file.xlsx. It will have 4 columns. At the first column there will be headers, first, second and third, and under these headers there will be numeric values, except this second row of the third column. There is an X ladder here. Okay, let's see how we can create a file like this. First I will create a matrix for the values. Let's name it as values. As you see, there is nothing in our workspace now. After I run this code, there will be values variable here. Okay, we created a variable named values. Let's see what does it have inside. As you see, it has 3 columns, 3 rows, all numeric values except this X here. Okay. Now I will create a headers file. First, second, and third. Also, we created here headers variable. It has 3 columns, first, second, and third. Now it is time to combine these and create an Excel file. For that I will use xlswrite function. My current folder location, this, is empty now. As you see, there is nothing in this folder now. Now we will create an Excel file here. It takes some time, as you see. Okay, it came here. Now we have a file in our folder called example file.xlsx. Let's look what does it have inside. As you see, it has 4 rows, 3 columns. At the first row there is headers, first, second and third, and under these headers there is numeric values and there is an X ladder here. And also I want to remind you something here. Be careful about how Excel names the columns and rows. As you see, Excel names columns as A, B, C, D, and the rows as 1, 2, 3, 4. For example, this cell is A2, this cell is B3, this cell is C4. It is good to know this, we will use it later. Okay. Okay, we completed the first part. At the second part, it says read numeric data from the Excel file. To read from Excel file, we use xlsread function. and I will equate it to A. As you see, it writes the numeric values to the screen, except this second row of the third column. There was an X letter here, as you remember, and it writes here none. It means not a number. Okay. In part C, read all the data from the Excel file. As we see at the screen, under the inside num variable, it has numeric values, and inside txt variable, it has just the text files. There is X here and the headers, and inside this row it has all the variables, including text and also numeric values. In part D, it says read a specific range of data from the Excel file in the previous example. Again, we will use XLS read, but this time I will define all parameters separately for you to understand better. I will define first file name. Now I will define sheet is equal to 1. I defined it as 1. Actually, in our example, there is just one sheet, but I just want to show you if you do not define it, it will assume 1 by default. Now I will define a range. From B2 to C3. Now it is time to combine them. Let's say our variable subset A. Now we will read inside it. First I am giving file name, and secondly I am writing the sheet, and the last parameter is range. As you see, the subset E just take from the cell B2 to cell C3. If we look at our original file, as you see, the B2 cell is this 2. To the C3 cell, it just take 2, 3, 5 and X. Okay. In part E, it says read the second column from the Excel file in the first examples. Let's name it as column B. We can do it also like this. We don't have to define it first. it will just have column B. It takes some time to read and write also to the Excel file. Okay, as you see, the second column is 258 and it reads to the it write to the screen to just second column. In part F it says read the first row this time. Let's see how we can read just a row. Let's name it as row A. Let's look. The first row is begins from A2 cell to the C2 cell and it ends up in C2 cell. We will write it here, A2 to C2, and it just reads the first row as you see. Okay, we completed the first part. In the second part it says open bedpoem.txt file, read the first line and then close the file. Okay, this bedpoem.txt is an example file, a built-in file in MATLAB. You can directly read it. You don't have to define it first. Okay, let's do it. First clear the screen. To do it, we will use fopen function. As you see, it returned 3. If there is no problem in the opening operation, it returns 3. If it cannot open the file properly, it returns -1. Okay, there is no problem now. Let's look what is this bedpoem. Let's type it to the screen. It's a just short poem with 4 lines: oranges and lemons, pineapples and tea, orangutans and monkeys, dragonflies and fleas. It is really a bad poem. Now I will read the first line by using fgetL function. As you see, I took the first line, just first line, oranges and lemons. Hence, I will close the file. If the closing operation is successful, it returns 0. In part P, it says now open the bedpoem.txt file, read all the lines. This time we will read all the lines and close the file. I will write this time in a script file. First, we will open the file bedpoem.txt. Now we will make the program read all the lines one by one. I will define the first line to a variable called tLine. Now I will write here a condition. If fgetLine encounters end of the file, it returns -1. I will use this property. If tLine is equal to the -1, if tLine is not equal to the -1, it will do these tasks. It will display the tLine. It will display the tLine, and then it will get the next line from the txt file. And then I will close the file. Okay, let's first clean the screen and run this file. As you see, it wrote all the lines, and when I close, if I put here a semicolon, it will not display here a 0. Let's run again. As you see, it reads all the lines. In part 3, it says create a sample text file that contains floating point numbers. In the previous example, we read from text file. Now it is time to write a text. First, clear our workspace, clear our screen. I will close this. First, let's create a randomly generated matrix with floating point numbers. Let's look what we have done. You see, we created an 8 by 2 matrix with floating point numbers. Now I will open my file to write into it this time. For writing, again I will use fopen function. This time I read here W letter because I am opening now this time this nums1 txt file for writing into it. In the previous example, we were reading from the txt file. Actually, we should write an R letter for reading, but even if you don't write it, by default it assumes it is opening the file for reading. Now we open the file nums1 txt here, as you see. And by using fprintf function, we will write into this txt file. Before I write it, let's look what does it have inside. As you see, there is nothing inside this txt file now. Now we will write into something in it. Now let's look what does it have inside. As you see, we write all the variables in our x to this txt file. Okay, because we have 4 letters after the comma, I write here 4, and we have 7 digits. Because of that, I write here 7. Let's write it differently, like this. If I write here, for example, 2, what will happen? I'm opening it again. As you see, this time there are 2 letters, there are 2 numbers after the comma, but it's still left 7 digits for the number. Okay, and I will close the file. Okay, we completed part 3. Now it is time for part 4. In part 4, it is asking us, by the following steps written below, build the table you see on the right. We will create this table. The first task is create a vector x from 0 to 1 in steps of 0.1. Okay, first I will clear my workspace. I will clear my screen. Let's close this also. X is equal to 0 with 0.1 steps to the 1. Let's check the x. As you see, it begins 0 and increase 0.1 steps up to 1. Okay, and the second part, it says create another vector containing exponential values of all the elements of x. And in the part C, combine these 2 vectors. Actually, we can do these 2 steps in one step, like this. Now we are taking all the exponentials of the variables in x vector. Let's look to A. Let's check it. As you see, e to the power 0, 1, and e to the power 1 is 2 point this value, and we took it in the second part. There is the exponential values of the variables in the first row. Okay, and then it says create a sample text file that contains these 2 vectors. Now we will write them to a text file. First, I have to open a text file. We already know how to do it. We did it in the previous examples. open x.txt. Because we are opening it for writing operation, I put here a W letter. And by using fprintf function, I will write into it I put here an S for scripts. Before I execute this command, I want to show you inside of this txt file. You see there is nothing. Now I will write inside it. As you see at the first step, we write headers. I write here 6s because I want to set my cursor to the 6th digit, and I write here 6, and I write here 12 because I want to begin this xx from the 12th digit, and this x means script, and this s will take this x, and this s will take this xx. Okay, now the headers are completed. Now I will write the numbers inside it. I put here F for floating point numbers, and again we will read floating point numbers because I put here F, and write this reverse flash N to go to the next line. And it will read from our matrix A. Let's look to the x.txt file. What does it have inside? As you see, again here we set the cursor to the 6th digit, and it begins from here and writes to the backward, and we set this second row to the again 12th digit, and it writes back. Because we put here 8, it writes 8 values, 8 numbers after the comma, and because I write here 2, it writes 2 numbers after the comma. Okay, and I will close the file. As you see, maybe we can compare these two files. with the one that we created. As you see, they are same. Okay, we completed experiment 7. Take care. See you later.